Hi everyone. Today we're going to go over the Earth and Space Science Regents exam, June 2025. So let's get started. So we're going to start with question one. First, at the beginning of the exam, it says, base your answers to questions 1 through 5 on the information below and on your knowledge of Earth and space sciences. Some questions may require the use of the 2024 edition reference tables for Earth and space sciences. Be sure to record your multiple choice questions on a separate answer sheet provided. Record your answers for the constructed response questions in your test booklet. So, very important information. Normally, when it comes to the Earth and Space Science exams, a cluster of questions, such as questions 1 through 5, are all related to the information they're giving you. So, a lot of times they'll give you paragraphs, graphs, diagrams, and so on, and a series of questions, and they will tell you initially which questions are all related. So in this case, questions 1 through 5, and you're supposed to use the information from all these sources they're giving you to answer questions. And sometimes, even if you're answering question 2, you might have to go back to the graph in question 1 because the information is related. And for a lot of the questions, like it says, you're going to have to look at your reference table for additional information to help guide you to answer the questions. So, before we get started, something that you should do every time you're reading through any um, information they're giving you on this exam is use a pen or pencil to underline or use a highlighter. Every time you're reading, you should highlight or underline any unknown words, word meanings, context clues, or important details on what the graph, diagram, or text is about, and any relationships between things, such as if X increases, Y decreases, and so on. When it comes to actually answering the question, any question they're giving you should circle the task verbs, meaning what is it asking you to do? And we're going to look at some examples in a bit. So let's look at our first text, our sun, a star. As I'm reading, I'm going to highlight or underline these things. And keep in mind that whatever I underline or highlight doesn't have to be the same as what you're underlining or highlighting, but you'll see that underlining or highlighting helps you break down the paragraph or text and understand it better. So here are my highlights. Let's read. Our sun, a star. The Hertzsprung Russell HR diagram was developed from star charts by two scientists in different countries independently of each other in 1911. I highlighted Hertzsprung Russell HR diagram because that may be an unknown word. I highlighted star charts because it looks like this and this are related. They are developed from star charts. And it also gives me context clues that the Hertzsprung Russell diagram is diagram related to stars. It classified stars, so I highlighted this because once again, it's telling me that this diagram is based on stars and classifying stars. So it's classified stars based on their surface temperatures, observable color, and magnitude. So I'm under highlighting these because some of these words may not be familiar. These may be unknown words for me. It also gives me extra context clues on what I'm supposed to find in the HR diagram. So maybe it should be giving me information on the star's surface temperature, color, and magnitude. So what is magnitude? I underlined or highlighted this, right? In the next paragraph, look, absolute magnitude is a measurement of how bright a star would appear if all stars are the same distance from Earth. So now I'm highlighting absolute magnitude because this seems to be the same as magnitude. And I'm also highlighting the definition of magnitude. So any unknown word meanings you should highlight. And it's a measurement of how bright a star would appear if all stars are the same distance from Earth. Okay, so now I can go back and know that the HI diagram must be about stars. It must have information on the star's temperature, its observable color, and how bright the star is. Next, the brighter the star, the lower the absolute magnitude value. This is a relationship as x increases, y increases, right? So the brighter the star, the more the star's brightness increases, what happens? The lower the absolute magnitude value. I know from previous readings, or the previous sentence, that absolute magnitude is how bright the star is. So the brighter the star, the absolute magnitude number should actually be lower. It should be a lower number. So lots of information here. It's less overwhelming if you highlight this. So, say I want to go back to this and I don't want to read the whole thing. I just want to get a gist of what this is about. Now, if I look at the highlights, look, the HR diagram, it's about star charts. It classifies stars based on surface temperature, observable color, and magnitude. Absolute magnitude is a measurement of how bright a star would appear, and the brighter the star is, the lower the absolute magnitude value. I already have a summary of this just by highlighting or underlining. Next, it says, I'm going to do this again. Number one, our sun is classified as a spectral class G star with a surface temperature between 5,000 to 6,000 K or Kelvin and an absolute magnitude of about 5. So our sun, I highlighted this because, okay, this might give me a context clue on what this whole paragraph or question is about. So our sun is classified as a spectral class G star, unknown word for me, or maybe for you. Um, with a surface temperature between 5,000 to 6,000 K. So it tells me that these numbers are just the temperature of the sun, and it must be a specific class G, and and an absolute magnitude. Remember that means brightness of about 5. So that's why going back to previous text is important. Based on the information, complete the HR diagram model by placing one X to indicate where the sun is located. I'm circling any task verbs, any verbs that they're giving me to do something, so I know exactly what I need to do to answer the question. So I need to complete the HR diagram, which I know is about stars, by placing an X. So I need to put an X somewhere to indicate where the sun is located. And I know I should know where the sun is located just by looking at these context clues they're giving me that I highlighted. Also, identify, I'm circling that, the relative temperature and the relative absolute magnitude of the sun as it transitions to a red giant. When it says relative, it means that I need to compare it to a red giant. So, what's going to happen to the sun's temperature and brightness or absolute magnitude as it becomes a red giant, which is somewhere here? So, once you start highlighting and circling everything, another thing you should do always is take a quick look at your reference table. Over time, you'll get so familiar with your reference table, this will get really quick, but please practice this for every question. So, I'm going to go to my reference table and I'm just going to look at the first page, the table of contents, sorry, and I'm just going to see where I can find any information about what I read from the paragraphs or questions they gave me. So I see page two has stuff about the solar system and also stars. Three also stars. Four has the HR diagram, which I read is the Hertzsprung Russell diagram. So that's probably where I need to go. And number five is the life cycle of stars. So many places where I can find extra information. If in case I have no idea what this is telling me or I don't understand, the reference table is here to help and give you additional information. So if I go to page two of the reference table, I see there's information about the sun. There's information about the period of rotation at the equator, the equatorial diameter, which is the size, and the axial tilt, which is how much it tilts. I see on page two that once again there's more information about stars, but this doesn't seem too helpful. There's all more information on page three about the emission spectra. This doesn't seem related to the question. But if I go to page four, I see the HR diagram and I see the sun right here and it's asking about red giants and I see giants right here and I see giants are red as well. It gives me color, it gives me temperature, it also gives me the spectral class. A lot of these things that they're mentioning here, spectral class, surface temperature, and so on. So I can see that the sun has a temperature of about 6,000 Kelvin or K, which tells me surface temperature, and it's spectral class G. And it looks like giants would be a higher mass and they would be a higher luminosity, and giants would also be a lower temperature, notice that if the sun is 6,000, giants are actually a lower number. So lots of information here. There's also some information on page 5 of my reference table that shows what happens to the sun's as in its life cycle. So it looks like sun-like stars become eventually in billions of years become red giants. So if you didn't know what this entire thing is talking about, here are more context clues for you in your reference table. Now you know that the sun may turn into a red giant in the future. A red giant is just a different stage of the sun later on in its life cycle, and lots of information about the differences in temperature, spectral class, and so on. Giants seem like they're in the spectral class around K or M. Let's go back to the question. Now I have lots of information and I know that I need to complete this model by placing an X to indicate where the sun is. And I already know where the sun is because of this. So it's really helpful, but you can also just use the information given to you here. And I see that the sun is the spectral class G. It has a surface temperature between 5,000 and 6,000 Kelvin, and it has an absolute magnitude of about 5. So I should connect them um right over here. This must be where the sun is, so I should place an X. And this kind of matches the sun over here as well in your reference table. Now I know that giants are right here and giants are here as well. And it looks like I need to identify the relative temperature and absolute magnitude of the sun as it transitions to the red giant. What happens to the temperature? Well, it looks like the temperature is decreasing from 6,000 to around 3,000 Kelvin. So I should say relatively red giants have a lower temperature than the sun, or the sun's temperature becomes lower as it becomes a red giant. And it looks like red giants have an absolute magnitude of 0, and the sun has an absolute magnitude of around 5. But remember, now I'm going back. The brighter the star is, the lower the absolute magnitude value. So this must mean that giants are actually brighter. So lots of information for you here. So for that one, I should say that the change in relative temperature from the sun to giants should be the giants should be cooler, there should be lower temperature, the temperature should be decreasing as it transitions. And the change in relative absolute magnitude should also be decreasing, or it should be a lower magnitude value. You'd also say this means that the sun is, the brightness is increasing. You can quote this: the brighter the star, the lower the absolute magnitude value. And it looks like the giants have a lower absolute magnitude value. And in the next video, we're going to talk about question 2. That's it.